Alrighty friends, so today we're going to solve some initial value problems using separation of variables type stuff. So here's the problem that we're going to start with. We're going to start with dy dx is xy and y of 0 is 1. So my first job is to separate the variables. So let's go ahead and divide by y and multiply by dx. You're trying to kind of treat the dy dx, that's my cat, you kind of treat the dy dx like a fraction. Okay, so I separated the variables, separate variables. You don't have to write down these steps, but for this first one in particular, I'm going to just so that you see what I'm doing. Now I have y stuff by itself and x stuff by itself, so I'm going to integrate. So I'm going to integrate dy over y, x dx, integrate both sides. And in order to do that, whose derivative is that 1 over y dy, so that's the natural log of y. Feel free to put absolute values in there, and then 1/2 x squared. Don't forget a plus c. You only need it on one side. The reason you don't need it on both sides is because if you put it on both sides, you could just combine them into a different plus c. And now I need to find that c value. I could wait a little bit, but I'm going to find it right now. So let's plug in 0 for x and 1 for y. Well, natural log of 1 is 0, therefore c equals 0. So we have the natural log of y. My cat just came up to join me. 1/2 x squared. Let's go ahead and solve for y. My students like to say e both sides. Y equals e to the 1/2 x squared. And we are done with that problem. Alright, our second problem is already formatted a little differently, just a little spice for us. X squared. Again, y of 0 is 1. So I already have the y over there, so I'll leave that alone. So I'll have y dy, and then x squared dx. So let's go ahead and integrate both sides. So that's 1/2 y squared. That's going to be 1/3 x cubed. Don't forget plus c. I like to find c whenever I can, so that looks like a good time now. 1/2 0 cubed is 0, so that means c is 1/2. That gives me 1/2 y squared is 1/3 x cubed plus 1/2. Now our job is to solve for y. So let's multiply through by 2. 2/3 x cubed plus 1. And then take the square root. Now, when you introduce this square root, technically we have a plus or minus there. We need to choose whether we're going to put a plus or a minus. We are going to put a plus. Here's the reason we're going to put a plus. We have a positive 1 there. If we did not have a positive 1 there, we would not have put a plus there. And our next question looks like this. Negative 2x, y plus 3. Again, y of 0 is 1. And so let's go ahead and separate those variables. So dy over y plus 3 is negative 2x dx. I always like to leave constants like the negative 2, that sort of thing, with the x, because I find it just makes my life easier. On the left side, that you should recognize that as 1 over y plus 3, which is the natural log. And then negative 2x, that's negative x squared. Don't forget plus c. As I have been doing, I'm going to go ahead and find out what that c is right now. Y is 1, so that's going to be the natural log of 4. X is 0, so c is the natural log of 4. So that gives me the natural log of y plus 3 equals negative x squared plus the natural log of 4. Again, we're going to e both sides, that whole thing. So that's going to be y plus 3. That's going to be e to the negative x squared plus the natural log of 4. Now, you could leave it like that, but I'm going to go ahead. Well, first I'm going to subtract the 3, but I'm also going to write it as e to the negative x squared times e to the natural log of 4, because that's a property of exponents. And then e to the natural log of 4, those are inverses, so that's just 4 e to the negative x squared minus 3. And that is my final answer on that one. And my last problem for this video looks a little extra spicy. We've got dy dx is x squared y plus y, x squared minus 1. In this case, y of 0 is 2. So let's go ahead and separate the variables. Well, first let's do some algebra. dy dx, let's take a y out. X squared plus 1, ooh, that got funky, over x squared minus 1. So now let's separate the variables. So we'll divide by y, and now we have x squared plus 1, x squared minus 1 dx. For the right side, let us go ahead and divide. So we have x squared plus 1 divided by x squared minus 1. So that's obviously going to go in once. And that's going to give me, let me change colors, x squared minus 1, subtract down. So that's plus 2 over x squared minus 1. So I'm going to keep rolling with the right side here. I'm going to do some extra work and we'll come back. That's going to give me 1 over y dy equals the integral of 1 dx plus, okay, so that's going to be 2 integral, that's going to be 1 over x squared minus 1, which is a over x plus 1 plus b over x minus 1. So this goes back to some partial fractions work. So that's a times x minus 1 plus b times x plus 1. If x is 1, then b is 1/2. If x is negative 1, then a is negative 1/2. So let's go ahead and take that 1/2 out. And we're going to have 1 over x minus 1 minus 1 over x plus 1. So on the left side, we're going to have the natural log of y equals x plus, so that's just 1, natural log of x minus 1 minus the natural log of x plus 1. And now we're going to e both sides. So y is e to the x plus the natural log of x minus 1 over x plus 1. And I guess I can keep rolling. Oh, plus c. And that's going to be e to the x, e to the natural log, so that's just x minus 1 over x plus 1, and then e to the c. And we had the point 0, 2. So in this case, I chose, because I got distracted by my children, but I chose to plug in for CE at the end. So y is 2, x is 0, x is 0. So that means e to the c is negative 2. And that's really all I need. So that's going to give me y equals negative 2 e to the x, x minus 1, x plus 1. And I did it.